All right, y'all. Welcome to a special edition of Math 1 with Mr. Green. So today we're going to be talking about the Pythagorean theorem. And the Pythagorean theorem is probably one of the most famous, most ancient, and probably most useful facts in math. Like you could probably ask your parents about what the Pythagorean theorem is, and they'll spit right back at you like, "Oh, it's a squared plus b squared equals c squared, huh?" So I asked my wife that, and she spat it back right back to me. So it's like pretty much everybody knows the Pythagorean theorem. Some of y'all might have seen it before, but we're going to go into it today and talk about what it's useful for, what we're going to use it for. Um, so let's go ahead and get into it. And so the Pythagorean theorem is basically telling us that the sum of our two legs of our triangle, if we square the two legs of our triangle and add them together, they're going to equal our third leg squared. So a squared plus b squared equals c squared. It's like the most famous line in math. A squared plus b squared equals c squared. But why a squared, why b squared, and why c squared? Why does that even make sense? Why does that make sense at all? And so a squared and b squared, we can kind of represent them as the area of a square with side length a, because a times a, right? That's how we get an area of a square. This is equal to a squared. And this b, this square with side length b times b, that gives us b squared. And then same thing with c. C times c gives us c squared. So we're going to kind of represent this using an area model. So we're representing a squared, b squared, and c squared as the area of our squares. And so this picture down here is kind of showing us like a visual proof of a squared plus b squared equals c squared. So what this is showing us is that if I took a triangle, so I have this triangle right here, and if I drew like a square to match like each of my side lengths, so if I drew a square for my side A and I drew a square for my side B, that the area of those two squares is going to equal the area of my hypotenuse square, my C square. And we can see that makes sense. Like A, we're saying is equal to, has a side length of 3 because we have this area of 9 here. So 9 plus 16 equals 25. And this is only true for right triangles. Right triangles have like this sweet spot where this is actually true. So if you have a squared plus b squared equals c squared, then it has to be a right triangle. And this statement works the other way too. So if you have a right triangle, you also have a squared plus b squared equals c squared. That statement goes back and forth. So this is only for right triangles. This is really important to remember, that this is only for right triangles. Because if we had an acute triangle, so notice now our side C here shrank. We took this angle here and we made it acute. We kind of shrank it so that C is smaller. Notice now a squared plus b squared doesn't hold up anymore because c squared is really tiny. So now a squared plus b squared, we said that was 25 earlier. That's not equal to 4 because we have an acute triangle. So this only works when we have right triangles. And likewise, if we took that angle and made it obtuse, still have the same side lengths though for a and b. So what we did was we blew up C really large. And now this is too big. It's too big and it doesn't match up with 25, which is what we found earlier for 9 plus 16. So again, this only works for right triangles. A squared plus b squared equals c squared only works for right triangles. Okay. Now, why do we care? Why is the Pythagorean theorem so useful? And so what we're going to use it for is we're going to use it to find the distance between any 2 points on a coordinate plane. And it's not too bad. It's really straightforward to use Pythagorean theorem to find the distance between 2 points. And so what we do is we just take these 2 points and we're going to plot them on our coordinate plane. So I'm going to plot the point x at 7, 8. And then I'm going to plot the point y at 1, 3. And what we're going to do is we're going to connect these two points with this like diagonal line here. This diagonal line is going to be our hypotenuse for our triangle. This is going to be our hypotenuse. This is going to be like, if we go back to slide 1, that diagonal is going to be like our c. It's going to be like our c squared. And so what we got to do now is we just have to make this into a triangle. And so in order to do this, so I have the point here at 1, 3. And I have this point here at 7, 8. So now for my horizontal part of my triangle, I just have to count what that side length is. I can just count what that side length is. So at 1, 3, so I'm going 1, 2, 3, 4, 5, 6. This side length is 6. And now for my top side length here, this is a right triangle, right? Because I'm connecting a horizontal and a vertical line. So now I just got to count that side length. 1, 2, 3, 4, 5. So now I have 6 and 5. And using Pythagorean theorem, I have a squared plus b squared equals c squared. And so c is always like opposite of our right angle. Our hypotenuse is always on the opposite side of our right angle. And so let's say this bottom length here is a, and the right length there is b. So then I have 6 squared. 6 squared plus 5 squared is going to equal c squared by the Pythagorean theorem. And so remember, 6 squared is just 6 times 6, right? Whenever we square something, we're just multiplying it by itself. And now I'm just doing the math. So 6 times 6 is 36. 5 times 5 is 25. And that equals c squared. 36 plus 25 is 61 equals c squared. And now we want to get the side length c. We don't want c squared. We need to get the side length c in order to get this distance between our point x here and our point y. That's my point y. This is x. So to get that distance now, I need to undo this square. I have 61 equals c squared, but I want c. So whenever you want to undo a square, if I have c squared, if I want to undo that, I have to take the square root. So like the opposite thing of a square is a square root. And so if I do c squared under the square root, that's going to give me c. And now I have the square root of 61 on the other side. And this square root, you could plug it into your calculator, but it's the opposite of squaring something. So like if we think about it, like the square root of like 64, the square root of 64 would be 8, right? Because 8 times 8 equals 64. And then I think the next one is like the square root of like 49 is equal to 7, because 7 times 7 equals 49. So it's like the opposite of squaring something. And so the square root of 61 is going to be somewhere in between. It's going to be somewhere in between 7 and 8. So if I plug that into my calculator real quick, I'm going to get c is equal to so we just plug this into our calculator. We get 7.81. And that's what I said, right? It's going to be somewhere in between 7 and 8. And so now this side length here for our triangle that we found is 7.81. So the distance between these 2 points is equal to 7.81. It's equal to 7.81. So we did that using the Pythagorean theorem. So we plotted our 2 points and we got that diagonal side length there, and then we just connected those 2 points with 2 legs, with 2 right lines, two perpendicular lines. That's the word that I'm looking for. Two perpendicular lines. So we just dropped a line down from X, and then we drew a line horizontal from Y so that we made our right triangle. And because the Pythagorean theorem says that if you know any two of your side lengths on a triangle, then you're able to find that third one using the Pythagorean theorem. So this is super useful. Like, people use this all over the place. Like, ship navigation. If I'm in the ocean, like, and I need to find the distance between another ship, like, all I need is their coordinates, and I can use the Pythagorean theorem to figure out how far that ship is away. Land surveyors are using this. Like, this is one of the most like useful bits of math I think that there is, and a lot of it is in finding distances like this. You can use it to like measure the height of trees. I think that's like another use for it. Okay, let's do another one. I'm going to try to keep this video as short as I can for you guys, but definitely don't want to skip over anything important. Okay, so now we're finding the distance between A and B. A is at -8, -4. And then we have 2, 5. Okay, so these guys are pretty far apart. But again, all we have to do, so here's A, here's B. All we have to do is just connect those two lines. And so now I just drew my diagonal, my hypotenuse of the triangle. And so then I just drop a vertical, right, to start making my right triangle. And then here's my horizontal line. And so now I just drew the two legs of my right triangle. This is a right angle here. So Pythagorean theorem is going to work, right, because this is a right triangle. And now I just need to count the side lengths for my two legs. I'm just counting units here. So from A to this bottom right-hand corner here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 units. And then from this bottom right-hand corner up to B is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. So now I have a triangle and I know two of the side lengths. I can use Pythagorean theorem here to find C, to find that distance between A and B. C is my distance between A and B. So again, Pythagorean theorem says A squared plus B squared equals C squared. A squared plus B squared equals C squared. Okay, and then this is 2, 5. And this is -8, 4. Just to be clear here. Okay, so then we have 10 squared plus 9 squared equals C squared. So 10 squared is 10 times 10. 9 squared is 9 times 9. Got 100 plus 81 equals C squared. And finally, 181 is equal to C squared. Now, don't forget, we have to do our square root. We have to undo this C squared because we're looking for C. We're not looking for C squared. We're looking for C. So again, I got a square root, and I got to do that to both sides. I have to make sure I do that to both sides. And then I just plug in the square root of 181 into my calculator, and that'll give me a decimal. And that decimal will be my side length. So I got 13.5 if I round it up. So 13.5 is the length of my hypotenuse. That's the distance between A and B. So that's how we're using Pythagorean theorem here to find distance between 2 points. Okay, so I'm going to skip this next one here and talk about the distance formula a little bit. So the distance formula comes from the Pythagorean theorem. This comes from the Pythagorean theorem. It looks crazy, right? Like, it looks like it's all this stuff, but it's no different from the Pythagorean theorem. It's no different at all. In fact, like, I can go back to the Pythagorean theorem if I just square both sides. I get d squared plus this thing squared plus this thing squared. And what these are just side lengths. So whenever you have a subtraction of two numbers, that's giving you like the distance between those two numbers. So what you end up with is like this would be side length A and this would be side length B. So you just get this thing that kind of looks like the Pythagorean theorem, because it is the Pythagorean theorem. It's the same thing. It's just kind of abbreviated, not even abbreviated. It's like this is what you would like plug into a computer for it to like compute the distance for you, like in one step, basically. But don't be alarmed. Like it's no different than the Pythagorean theorem. And so I'll show you how this works here on the next slide. So we'll do an example. Let's see. I think, yeah, this will be fine. Okay, 7, 8, and 1, 3. So again, 7, 8, and 1, 3. All right, so it wants us to use the distance formula here to find this distance, to find that diagonal distance. And so again, so here we go. This is 7, 8, and this is 1, 3. Okay, so what the distance formula wants us to do is to go x2 minus x1 squared plus y2 minus y1 squared. And so x2, so like x1 and x2 are talking about like this is like the first x coordinate, this is like the second x coordinate, and like this is the first y coordinate, this is the second y coordinate. That's what this is talking about. And so it wants us to go x2 minus x1. So x2 would be 1, right? And then x1 would be 7. And then it wants us to square that. Plus, we're going to go y2 minus y1. So we're going to 3 minus 8 squared. Okay, and so then we get negative 6 squared plus negative 5 squared. And it really doesn't matter like if you do x1 minus x2 or x2 minus x1. So notice here we got negative numbers, but when you do the square, like it gets rid of the negative numbers anyway, so it doesn't matter. So this negative 6 squared is just negative 6 times negative 6. And this negative 5 squared is negative 5 times negative 5. So those negatives end up turning positive anyways. So we get square root of 36 plus 25. Finally, we get the square root of 61. And this is exactly what we found on the previous slide when we did this. If you can recall, we did this before on slide 3 here. And notice like the 6 and the 5, we found 6 and 5 in our distance formula, because all the distance formula does is it subtracts two numbers. And when you subtract two numbers, you end up getting the length between those two numbers. So when we subtracted 7 and 1, we got 6. And when we subtracted 8 and 3, we got 5. So that's all the distance formula is doing. It's doing the same exact thing as the Pythagorean theorem. And so I think a lot of people prefer doing the Pythagorean theorem over the distance formula, because who likes to memorize a formula? I don't like to memorize formulas. So personally, my personal choice is to draw that triangle and use the Pythagorean theorem just by counting. And you don't even have to count. Like you could say this side length here is because this is at 7, right? If you draw this down, this is at x equals 7. And if you draw this down, this is at x equals 1. And so really this side length here is 7 minus 1, which is equal to 6, which is what we said before. And then up here, if we draw this back, this is at 8. And then this bottom part here is at 3. So now we just have 8 minus 3, which gives us 5 for this side length. And so again, you just get 5 squared plus 6 squared in order to get your c value, which we already found is square root of 61, which is what, like 7.8 or something? 6.8? Oh yeah, 7.8. Okay, so that's the distance formula way. So if you like the distance formula, if you like to memorize formulas like that, that's fine. But if you want to draw triangles and use Pythagorean theorem, that's also fine too. Okay, so that's our distance formula. And so what we're gonna do is we're gonna use this distance formula to find perimeter, because perimeter is just adding up all of these side lengths, right? So we're going to find the side length for this, the side length for that, the side length for that, and the side length for that. And finally, the side length for that, and add them all up to get the perimeter. Now, I'm not going to go through this whole example, but the way we would do this, right, is we would use our Pythagorean theorem to draw our little triangles here. So we'd have a little triangle here, and we would just count how many units this is here. 1, 2, 3, 4, 5, 6. And then on the side, 1, 2, 3. And then so this side length here would be 3 squared plus 6 squared equals c squared. And then you draw your triangle for this guy. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And so this side length would be 3 squared plus 8 squared equals c squared. And you're just doing that for all of these all around this figure, making little triangles and using Pythagorean theorem to find the length of those slanty lines here. But what about this vertical one? How do we set up a triangle with this one on the right here? How do we set up that triangle? And the answer is you don't need to. You don't need to use Pythagorean theorem for this, because you could just count how many units this is. 1, 2, 3, 4, 5, 6. That's 6. That one's kind of given already. You're just counting how many units. You don't have to do Pythagorean theorem when it's either vertical or horizontal. We only use Pythagorean theorem to find those diagonal lines, right? Those slanty lines, those what we've been calling hypotenuse. So yeah, that's how we're going to use Pythagorean theorem, and how it is related to the distance formula. And our application of that is going to be to find perimeter of these given polygons. So I think I've gone long enough here, but I hope this helps, and I hope it helps you to get caught up with your homework, and so that we can get caught up with our other Math 1 classes, so we're not always playing catch up for the rest of the year. Okay, all right, I'm done. So have a good day, everyone, and we'll see you in class next time.